Hello again. So in this video, we're going to talk about slope. Slope is one of the most important standards that we cover in 7th grade because you will use it for as long as you have to take a math class. There's a lot of graphing in math, and everything kind of builds on this concept of slope. So I've got a lot to cover, but hopefully this will help you with your homework if you're feeling stuck or if you've been absent. Slope is also the rate of change. We've covered rate of change already. We've talked about how it's the amount of change shown in the y values compared to the amount of change shown in the x values. And I think I even said in that video, because I usually say in class, that most teachers refer to slope as rise over run. Rise is if you get up, right? You move upwards. So that's your vertical change. And then run is how far you're moving horizontally. It's your horizontal change. I always tell my students you rise to the top. So wise go to the top because rise rhymes with wise. When you write your slope, it's either going to be a whole number or it's going to be a fraction. You want to reduce it if possible. Don't ever write your answers as mixed numbers or decimals. We're going to be using slope to graph. It's directions for how to move, and you need two of those directions. You need a something over a something. So don't make it a mixed number. Don't make it a decimal. First thing we're going to do is find the slope if we're given a graph. So what you want to do is find two easy points on the graph. The ones I'm going to show you here in this video, I've already got the points, like the actual points on the graph, but you'll see sometimes in your homework or on tests that they won't always have those points like highlighted, the little dots for you. So what you want to do is look for where they go through corners of grid boxes because you want to work with whole numbers. Pick two of them. Start with the one that you pick that's furthest to the left. You're going to count how many moves it takes to get from that point to your second point that's more to the right. You want to see how many you go up or down. That's going to be your top number. Positive if you move up, negative if you had to move down. Your bottom number is how many you ran over to the right? Rise over run. There's pictures there at the bottom. The graph that I have in red, you read a graph like you read a sentence from the left to the right. If it's climbing, then it's a positive slope. It's moving in a positive direction. The blue one that you see there at the bottom from the left to the right is falling. It's moving in a negative direction. Okay, so let's do some examples of these. So I've got three graphs here, and what I was talking about with those points, see how these already have, let me change my color so you can see what I'm doing. These already have little points on them, right? But they don't always. Sometimes it'll just be the line. So look for where they go through corners of grid boxes. Pick any 2 points. Pick points that look like they're going to be easy to work with. If you don't like negatives and you have positives as an option, do that. Just pick any 2 points. I'm going to use this one because what's easier than 0, 0, right? And then I'm just going to use the next one that I see here. That point, to get there, I have to go over 3 up 2. So that's at positive 3, positive 2. Remember, in my points, the first number tells me how many to move right or left. The second number is up or down. Slope is basically the opposite of that. Instead of going side to side first, we're going to go up or down first. Sorry, that's the bell for the 8th graders here. So I want to look at how many moves it takes me to get from this point to this point. I want to check my vertical change first. To get from one to the other, I have to go up 2. That's moving in a positive direction. So my top number is a positive 2. From there, just make like a little triangle. So we go up 2. I've got to go over 1, 2, 3. 2/3 doesn't reduce. That's my slope. That's all you have to do. Number 2, as I look at my graph, I see that it's falling from the left to the right. It's moving in a negative direction. So I should be getting a negative answer. Pick 2 points that you feel like are going to be easy to work with. Excuse me. Doesn't matter which 2. I'm going to do this one and this one. And remember, I keep saying this, but if they don't already have the little dots there for the points, find where your line goes through corners of grid boxes so that you're only dealing with whole numbers. So start with the point that we marked here that's furthest to the left. To get from that point to the next one, I have to fall down 1, 2, 3, 4 times. Because I'm moving in a negative direction, that's a -4 on top. And then I have to go over 1. -4 over 1. Now, when you have a negative fraction, it doesn't matter if you have it with the top number, if you have it with the bottom number, or if you just have it out to the side. It all means the same thing. One fraction makes the whole thing negative. Or, sorry, one negative makes the whole fraction negative. So for this one, you can leave it as -4 over 1, or you can just say -4. When we're graphing, we'll want the 1 on the bottom. But when you're just writing the slope, honestly, it doesn't matter. Let's do one more of these. Pick 2 points that are going to be easy. So usually I would do 0, 0 if it goes through the origin. But let's say you didn't notice that right away and you just picked 2 other ones. Let's do this point, and let's even go to this one here. Maybe in our homework problem, we don't see the actual dots and we just pick those 2 places where it hit corners of grid boxes. When you reduce, it's going to be the same. Your slope of a line is the same no matter which 2 points you go between, because your slope is consistent. It's constant. It doesn't change. That's what makes a line a line. So to get from my first one to my second one, I have to go down 1, 2 moves. So that's a -2. And then I have to go over 1, 2, 3, 4 moves. -2 over 4 is really -1/2 for that slope. It's going to be the same kind of deal when we're given a table of values. You have to focus on the y first. Just always remember my dumb little saying, you rise to the top, so y's to the top. Rise rhymes with y's. The slope will be the same, like I said, between any 2 points. So you don't have to do this 50 bajillion times for your table. Just pick one pair and find the slope. I just wanted to show you if your if your table is set up vertically like this, x is on the right, y is on the, oh my gosh, I can talk today, can't I? X is on the left, y is on the right. I promise I know my directions. If your graph is set up side to side, X is on top, Y is on bottom. So it's going to feel like you're doing them upside down on that one. Okay, let's do some examples for those. Now, the first couple I put on here, I put labels. That way we can practice with what's the X and what's the Y. Number 1 is a vertical table. So this is my X. This is my Y. Pick any 2 points. I'm just going to look at the first 2 that are listed here. I want to focus on the y's first. You rise to the top, so y is to the top. To get from 100 to 80, that's 20 moves, but it's going in a negative direction, right? You're losing money. You're falling in a negative direction. So I'm going to put -20 for my top number. On the bottom, to get from 1 to 3, I'm increasing by 2, so that's a +2 on top. To write my slope, I can call this -10 over 1, or I can just call it -10, either way. Let's look at number 2. When your table's set up horizontally like this, your top is your X, your bottom is your Y. Oh, good. Here it goes with not wanting to write. Come on, little buddy. You can do it. Oh, my goodness gracious. It's always something, I swear. There we go. X and Y. Rise to the top, so Y is to the top. So we're going to focus on the Y's. I'm just going to do these first 2 set of points there. You got to love when everything works fine until I start recording, and that's when things go wonky. To get from 5 to 15, that takes 10 moves in a positive direction. So 10 goes on top. On my X's, to get from 1 to 6, that takes 5 moves. So 5 goes on bottom. And then you need to reduce. You can call that 2 over 1 or just call it 2. Number 3, focus on your Y's. Pick any 2 points. I'm just going to do, I usually stick with the first ones, just, I don't know, just because. On my Y's, to get from 1 to 5, that takes 4 moves in a positive direction. And on my X's, to get from 0 to 3, that takes 3 moves in a positive direction. Do not rewrite that as 1 1/3. You'll see in a little while you want something over something. They're directions for how to graph. So I need to leave this as 4 over 3. For every 4 it climbs up, it runs over 3 is what that means. The slope determines how slanted your graph is, how steep or how shallow. That's all based on its slope. Okay, next one. I'm just going to do the first 2 points. Y's first. To get from 0 to 1, it takes 1 move. To get from 0 to -4, I have to go backwards 4 moves. I've got to move 4 in a negative direction. So -4 goes on the bottom. You can write it like that, or if you don't like the way that looks, just put your negative out to the side. It all means the same thing. -1/4 is my slope. Okay, third type of problem where you'll be asked to find the slope is if you're just given 2 points. This is no different than what I've already shown you. If you're more comfortable with the graphs, I'm sure you can get graph paper. If you're in my class, I have graph paper available that I can always pull out if it helps you. Or even if you're online, you can get coordinate planes and things that you can use. But you can plot your points and literally count how many up or down and then how many over. Just like we did with the table, what I do really is I count moves. Now, in reality, there's this thing called the slope formula. And a lot of teachers will probably tell you, you take y2 minus y1 over x2 minus x1. And that is what I do. I just think that looks a little bit confusing, especially when you're in 7th grade. So I do that, but I simplify my explanation a little bit. I'll show you. If you're going to use that formula, I'm going to call this x1, y1, and I'm going to call this x2, y2. So y2 minus y1, I'm going to do 2 minus -1. And then x2, I think I said that backwards, y2 minus y1. I'm doing really well today, folks. X's, I'm going to do 4 minus 3 for x2 minus x1. On the top, there's a face problem. If you're one of my students or you've watched my videos, you've heard me talk about face problems. I'm going to replace the face with a plus. So that becomes 2 plus 1, which is 3. And on the bottom, 4 minus 3 is 1. My slope is 3. So a couple of years ago, I had a teacher show me this. She stands her points up like this. She rotates them. She goes, shoop. So when she rotates like that, the -1 goes on top, the 3 goes on bottom. She rotates the next one, 2 goes on top, 4 goes on bottom. Make it a fraction, put minus in between. And then she works out that subtraction. So she would have gotten -3 over -1, but those negatives cancel. So that still gives you a +3 or +3 over 1. It's the same thing. So there's another idea. I told you I simplify a little bit. I'm doing subtraction, but really when you subtract, what's happening is you're finding out how many moves are in between. So I do this. I start with my y's, of course, because rise to the top, y's to the top. To get from -1 to 2, it takes me 3 moves. Then I look at my x's. To get from 3 to 4, it takes me 1 move. 3 over 1 is my slope. It's all the same. It's just different ways to think about it, different ways to look at it. Okay, number 2. I'm going to do that last method that I just showed you because that's just my habit. That's what I'm most comfortable with. But you do whichever way makes most sense. We're all going to get the same answer. Y's first. To get from -5 to 1, it takes 6 moves, right? 5 moves to hit 0 and then 1 more. So that's 6 moves. On my x's, to get from 0 to -6, well, that's also 6 moves, but it's going in a negative direction. 6 over -6, we can reduce that to -1 over 1 or just -1. Let's do some more. Number 3, y's first. You always, always, always do your y's first. Rise to the top, so y's to the top. To get from 0 to 4, that's 4 moves. And then to get from 2 to -3, that's going backwards 5 moves. If you don't like the way that looks, I know it kind of bugs me too, having the negative on the bottom. Just rewrite it. -4/5 is our slope. Number 4, to get from 8 to 6, it takes 2 moves backwards. That's -2. To get from 0 to 4, that's 4 moves. I can reduce that and rename it -1/2. Let's do a couple more. And just to warn you now, these are weird ones. Number 5, to get from 1 to 1, you're already there. That's no moves, right? If you want to go ahead and put 3 on the bottom, you can, but we're going to simplify this. We talked when I taught you how to do multiplying and dividing integers. We also talked about dividing when zero's involved. If zero's on the top, if you're in a race and you come out on top, that means that's a good thing, right? You won. So this is the good version of the problem where you get an answer. That answer just happens to be 0. Your slope is 0. It has a slope. 0 is a value. It's just an empty value, but it's still a number. So it has a slope. If I plotted those points, 9, 1 is like here somewhere, 12, 1 is here somewhere. It's a horizontal line because there is no rise. It runs over side to side, but it never rises or falls. So a horizontal line makes 0 on top, gives you 0 for an answer. Let's look at the next one. To get from -2 to 2, that's 4 moves. But look at this, 8 to 8, you're already there. That's no moves. So back in the day, we talked about when 0's on the bottom. If you're in a race or contest and you come out on the bottom, that's not good, right? That's the bad version. Bottom and bad both start with B. So this is the bad version when you cannot do it. We talked back then about how we could call this no solution. Well, in this case, it's slope. So we could call this no slope. Or the answer is undefined, which means the slope is undefined. That's the technical term for it. But it happens when you have no slope. If you look at where those points are, so 8, -2 is like here, 8, +2 is about here. It's a vertical line. It rises and falls, but it never runs over. So the run is a 0, your bottom number is 0, which means you cannot get a slope. All right, last but not least, you are also most likely, when you take the state test, whether it's I Learned for Indiana or you're somewhere else, you're going to have to graph a line given a slope and a point on the line. When you get to 8th grade and beyond, you're going to be doing this so much. It's really, really easy once you get the hang of it. We're going to follow these 4 steps. You're going to plot the starting point. You're going to make sure your slope looks like a fraction. If it's positive, that slope is going to tell us how to move up and right. If it's negative, it's going to tell us how to move down and right. I never, ever move left. It's too easy to get myself confused. It's either up and right or it's down and right. From that point, you're going to move, or from the first point you made, you're going to move according to your slope, like we just talked about. That gives you a new point. Then you draw your line. You want to go through the points, past the points with arrows on both ends because lines continue on infinitely. So I think I've got 4 here to show you, and then we'll be all done. My first point here is 0, -3. That means don't go right or left, just go down 3. I want to make sure my slope looks like a fraction. So I'm going to turn 5 into a fraction by putting a 1 on the bottom. It's positive, so that's telling me up and right. So from that point that I made, not from the origin, from the point I just made, I'm going to travel up 1, 2, 3, 4, 5, and over 1. You could do it again if you want. You could keep stair-stepping. Up 5, over 1, up 5, over 1. You really only need to do it for 2 points. Then you go through the points, past the points, arrows on the ends. Hopefully yours comes out a little straighter. I can do it much better on paper. It's much harder when you're on a tablet like this. All right, number 2, I'm going to plot the point 1, 4. So that means 1 right and 4 up. From there, my slope is already a fraction. My slope is negative. So it's telling me down and right. Don't ever try to go left. It's up and right or it's down and right. So from that point I just made, I'm going to travel down 3, 1, 2, 3, and over 1, 2, 3, 4. Through the points, past the points, arrows on the ends. 2 more. Number 3, -2, 1 is left 2, up 1. My slope is already a fraction. It's a positive slope, so it's telling me up and right. So from that point I just made, I'm going to travel up 2, right 1, 2, 3. And do it again if you want. Up 2, right 1, 2, 3. They're always going to fall in line with each other. Through the points, past the points, arrows on the ends. Can you tell my allergies are bad today? I sound all stuffy, like I'm holding my nose or something as I'm talking. Number 4, 0, 2. Don't go right or left, just go up 2. From there, I need to make my slope look like a fraction. So I'm going to put 1 on the bottom. My slope is negative, so it's telling me down and right. So from that point I just made, I'm going to go down 2, right 1. Do it as many times as you want. Down 2, right 1. Down 2, right 1. They're always going to land in line with each other. Through the points, past the points, arrows on the ends. That was a whole lot of information. In class, this year's a little bit crazy because with our COVID restrictions and having A and B cohorts and only seeing everybody 2 days a week in person, we'll probably combine into one lesson and just review like I did here in the video. On a normal year, I usually separate that up into 2 different lessons. So if you're not one of my students and you've come across this, you may not need all of that at once. I would encourage you to go back and rewatch any of the problems that you felt like you didn't quite get. Slope is one of those things that is often very, very difficult at first for 7th graders. But once you get it, you really get it. And you realize it's so easy and it helps with everything in the future with graphing. So don't give up on it. Keep plugging away. I know you're going to get it. As always, thanks for watching. Until next time, bye.